Alright, so now I got the stepper motor, the larger one, mounted on the top of my pulse motor, being rectified. The two sets of coils in here are just, in series, and then that's really not the right way to do it. I'd have to have two separate bridge rectifiers, but I only have one. So I'm just having them in series, and then I'm rectifying it like that. But this is the capacitor bank that I'm charging from the stepper motor. It is at 4 point and climbing 4 volts. I'm using my large. It's at about 950. That's the output, but I'm just gonna say it's 1,000 just to keep things simple. And this is the current draw. So if I say this is 1,000, that is exactly 1.2 watts, 1.8. So at the most, it's pulling about 1.8 watts, 1.2. So but that's just to keep things simple, because this is almost 1,000 volts. So it's technically a little bit lower than what it's showing, but it's not by a large factor. So in order to turn this, that's how much current is being pulled to turn the stepper motor, which this thing takes a lot of power just to turn it. There's a lot of drag on this motor. That's why I don't really want to use this thing. But I mean, it's technically it's working at the moment, but it's not self-powering due to the amount of output and how much drag there is on this motor is a big factor in losing energy, and this conversion is not great either. But I have it working and it's powering. But it's just not ideal. I don't know if this is really not the greatest for this. It does generate 4 volts at this RPM, which is not bad. But I think I could probably do better. And I could definitely eliminate a lot of drag just from it running. So now when I pull power, this is just a 20 volt or a 20 kilovolt step up transformer. But as soon as I touch these leads on here, it just drains this like instantly. Because I could use this to power the motor, but it's just not practical, and it drains this capacitor bank very quick. Either way, I can't. I'm gonna have to get this tripod on here again. So I'll show you by doing this. You can see how quickly it drains that voltage on here. See how that little bit of time? So I can't consistently run this, because this little thing has enough power to actually run it at this speed, but it pulls way too much power. But now if I grab this other one I got, if I use this one, it generates, I believe, like 5 kilovolts. But this is only running on 1,000 volts, so if I get one that's maybe rated for exactly 1,000, it might be better off because it won't pull as much power. But even said, I'll stop around like 3 volts, and it still struggles to run it. Let's do this without shocking myself, right? I just want to get the leads close to each other so maybe they'll make a little noise. Alright, you can see that, and that's good. No, not enough. But it's connected and it's draining, but it doesn't drain quite as fast. But it's still draining too much. And that's really not pulling really much power from it. Now if I just short it out, it's going to drain really, well, actually it's not draining anything. So if you short it, doesn't really drain much. Doesn't drain at all. But this one almost works enough to keep it running, but at the same time it's still struggling. So right here, it's not barely powered on. It is on, but barely. So it's still running, and it's just barely keeping up with it running at that voltage. And the current on here is still staying about the same. Oh shit! No. Well, I'm gonna have to stop the video now because this is kind of a mess. That's what happens if you have wires hanging all over the place. Yeah, well, yeah, that's just the status quo of this current setup. So, yep, I'm gonna cut it off here, and that's where I'm at the moment. So, yep, that's that. See you later.